Welcome to the Emerging Technologies Roundtable. I'm joined today by Abby Eon, SVP and General Manager of our Kepware business, and by Howard Heppelman, DVP and GM of our ThingWorx IoT solutions. We're here to discuss how companies like yours can and are connecting their products and operations to close the loop of product lifecycle, drive more efficiency, and improve quality. Abby, Howard, thanks for being here. Let's just get started with, how does PTC think about IoT? Howard, let's start with you.
Yeah. Well, I think, the industry in general has for a long time connected to IT systems, or you've connected to equipment in the factory. The real opportunity here is the bridging or the convergence, as is popularly known in the industry, IT-OT convergence, of bringing that data together and then creating a context of that data that can be used to unlock new business processes, draw new insights, et cetera. So that's really, what we're talking about when we're talking about IoT is how do you bring information technology, equipment or operational technology together in the realm of the user to give them new capabilities, new insights, to enable new processes and transform businesses.
Both for, let's say, factory and for things out in the field, service, both.
Yeah, absolutely.
I think traditionally when we think about operational data like Howard is talking about, there's a lot of, let's say, a disconnect between how the IT folks and the OT folks are thinking about that data, and almost all of it is siloed to some fashion. So we're thinking about companies trying to build this management process configuration, and we have data that's on the ERP, maybe PLM, CRM that's not connected. And similarly in the factory, we have a bunch of production systems. So getting those teams to understand that data and those silos and bringing them together is where a lot of power in IoT is.
Yeah, I know, it's interesting. It's I think you both know at one point we used to say, hey, Windchill is the single source of truth for all product data. And I think what you're saying is, hey, maybe not so fast, meaning there's important data in MES systems and factory systems, in ERP systems, and other data silos that exist in the whole enterprise. So yeah, it's interesting. So let's move to the next, because our audience is, it's PLM customers. And so let's just talk about the forward flow of PLM data, that richness of PLM data that's trustworthy, and its use in IoT use cases. Howard, let's start again with you.
Yeah. Well, I think, if you look at great customers of ours like Vestas, for example, who's been featured, and you think about, they're starting with managing that single source of truth around the product data. But quickly what they realize is there are opportunities to extend that data, to extend it into manufacturing, to extend it into service. So one of the very first things that they start looking at is how do we take that engineering bill of material and repurpose it so that it looks like how we're going to build those products on the shop floor. Then how do we take that bill of material and plan all the operational steps, the process, the routings, the tools and resources, skills, the cycle times that we expect it to take, and then deliver that content down to the shop floor. So there's a very logical transformation that happens, which digitally threads the engineering function and the products that will be built to the factory floor where those products will be built. And then it's about how do you use technologies like IoT in a work center to combine that equipment data and that product data, right, and enable the operators to, quite frankly, be far more efficient in executing configuration-specific builds on the factory floor. On service, it's very much the same kind of path, except instead of transforming the engineering bill of material into a manufacturing bill of material, we're now thinking about how are we going to service that product? What is the serviceable bill of material? And so we're bifurcating the bill of material down to a view of what that looks like in service. But the same steps basically exist. Then how are we going to lay out what the service work instructions would be, how long that process should take, what steps an operator is going to go through, and then ultimately deliver that information out to the technician on the front line who's trying to get a piece of equipment restored as fastly as possible to minimize any unplanned downtime.
And I think a lot of that, when we think about automation and how that's tying in, so some level of automation in the processes, because a lot of these things have been on paper and have been manual. But as we bring this out and think more about how we can automate even the production, because now we have more insight into how we're setting up that operation, we're able to bring more data in. So another example of where we are bringing in IoT data to start getting input and then feeding data back.
Yeah. So just to maybe add and ask you both a question is, part of it is, of course, as you talked about, Howard, the forward flow of data, instructions and parts lists and things like that. If you think about a maintenance scenario in the factory or the service scenario in the field, kind of understanding the condition of that piece of equipment is also pretty important, in the moment and in the lead up to that. Can you talk about IoT data from that perspective?
Yeah, I mean, let's talk about the field for a second. Obviously, when you connect the equipment with the data, and especially over time, you're going to get much better insights about what specific pattern is occurring with that equipment in the field and what are the fixes that need to be deployed to restore that equipment. The same is absolutely true in the factory. When we deliver that information down and we connect it to the operational environment in the factory every day, we can start to harvest the analytics and insights around the equipment to drive better responses and better fixes.
I think when you think about operational data, with a company like Vestas is a good example. They're manufacturing product that is out in the field, and that historically, utilities, power, those are places where they do actually gather a lot of operational data. It's really thinking about the new use cases. Where do you leverage that data for new use cases and be able to do even more than you had before?
Yeah, actually, so speaking of that, now we were talking about the forward flow of data. Now let's talk about the return trip. If we think about closed loop, we talked about the forward view, and now let's talk about the return view and the use that we can get from IoT data, back in engineering, let's say. Howard, let's start with you.
Yeah, I think this is actually probably the most exciting part about it, because what we're talking about here is not just the delivery of that information, but as we all know, whether it's in the field or in the factory, there are always going to be there's a context to what's happening in that environment. And so if we focus on the factory, for example, we've planned what the factory should look like to build the product. We've designed the process, essentially the digital twin of what we expect that process to look like. And now people are showing up every day in the factory and trying to do that work. And guess what? It doesn't always go exactly as we planned. The beauty of the return trip is that it closes the loop on that. And so now we understand we expected this particular action to take the operator 2 minutes to do. That action always takes 3 minutes to do. Maybe we need to think about how we redesign the process element of that. Or this other particular operation, when using this type of equipment, always has a quality issue. Now we can bring that data back and either think about redesigning the process or maybe redesigning the product itself. That closed loop capability is super important to be able to drive a culture and system for constant and continuous improvement.
Yeah. And if you extend that really into those service use cases and you have that digital twin, when you think about it, that's linking ideally your engineering data, how you've built your BOM, how it's been manufactured, and now it's in the field, and now you're getting feedback from when it's operational in the field that's going to inform not only service decisions, but all the way back to engineering and those products.
Yeah.
Yeah, and if I just might add to that, in the field, I think one of the really critical things here is, again, delivering configuration-specific data to make, whether it's the dealer, whether it's the customer doing self-service, or whether it's the Vestas team, for example, and their service organization repairing that equipment. How do you make sure that the context the operator is in is precise to whatever configuration of the product? That has to come, it starts right up front in PLM. But then again, looking at how is it the work that they're performing and where are the opportunities to get better, to constantly drive better service, to get the failure data from the field, to better engineer that next generation of products. So closing the loop, whether it's in the factory or in the field, as Abby said, is really critical to driving sort of a step change in performance.
Yeah. So, I mean, this is all of our thinking, and there's lots of possibilities. Of course, PTC is a solutions company, not necessarily a toolkit company. And so let's just talk about our IoT solution strategy. Clearly, there's been sessions on Navigate, and that's kind of the engineering piece of it. But Howard, can you just talk more about the things we're doing in the factory and the field?
Yeah, and let me do it, though, through the lens that we were just talking about. If we think of a closed-loop digital thread that starts in engineering, makes its way to the factory floor, and then brings data back again. What's in the portfolio that does that? Well, clearly, you've got Creo and Windchill, and you've got NPM Link, which is used to essentially transform the bill of material and create that a desired digital twin of the operations. But then we're making that handoff into the ThingWorx solutions like Connected Work Cell, which is the vehicle for delivering that content on the shop floor to the operators, but we don't stop there. Connected Work Cell is looking at also how does the process itself unfold for the operator. So we're gathering all those metrics that were designed in NPM Link. We're now saying what's actually happening on the shop floor. Yeah. And then we're able to feed that data into the cornerstone of our factory solution, which is digital performance management, to look at, are those kinds of problems the one that are showing up most frequently that are actually constraining the overall throughput of the factory? So by designing the performance, executing it, measuring it, feeding it into an engine that helps you understand where does it rank in terms of the overall priorities, we can actually create a closed loop to the digital twin of the process by measuring the actual performance of the factory and get the organization focused on what are the principal and top opportunities to drive financial impact.
Yeah.
Again, same scenario plays out in the field. Started in Windchill, Creo, Windchill. This time again, we're creating that service bill of material. We're creating the work instructions and tools like ArborText and to deliver those. And then we're again measuring it through the connected work cell type application in the factory to monitor and measure and bring that same data back to continuously drive improvement in the overall process.
I think what's really key too on the solutions note is, like Howard said, starting with that business value, because when we start thinking about digitization and democratizing data, there's no shortage of data you can start collecting. So I think a lot of companies start to get into trouble because they have a bunch of data and they're building out twins and they're building out these enterprise architectures for data. And if you're not thinking about the problems you're trying to solve and what's the highest value, like that is just a critical place where we see failure and we see things being stalled.
Yeah, and if I could add to that again, I think if you step back 50,000 feet, and now let's talk about the service example or the field example for a second. Why is PLM data so important to companies like Vestas and many others? And what it really boils down to is we all know that value is shifting from mechanical to software and increasingly from sort of on-premise systems to the cloud. And what having that digital thread unveils is strategic opportunities for customers through capabilities like digital product platforms. We're all familiar with the success that Tesla is having. You pull your car into the garage at night, you plug it in, and not only does it charge, but when you wake up in the morning, it probably has new capabilities in it that you didn't have. This idea of creating digital product platforms that make their way into the field, but are tethered back to the actual configuration, the embedded software, all those capabilities that we can now update, unlocks an entirely new way for our customers to think about how they're designing their products. Maybe most of the engineering is actually done after the platform is put into the market, for example.
Yeah.
And none of that can be done if you don't have the configuration-specific context that started up front in engineering.
I agree. It's interesting. A whole nother topic on kind of design for connectivity, for connected service, or connected manufacturing, or connected customer support. So a lot there. So let's reel back a little bit and just say, okay, if you were to give someone some advice, how do you get started?
I think foundationally, it is a data foundation. I mean, you hear it a lot on digitalization, like I mentioned, like with EOP and PLM systems and CRM. But then in the operational space, you need to do the same thing, and that's been tricky because factories are largely heterogeneous. Either in a site or across an enterprise, everything is a little different. So you need to start collecting that data, but you also need to realize that even though things vary from site to site or even line to line, you need to level some, consistency where you can abstract the complexity and create these cleaner models that you may not have your single source of truth, but you want to build that up in easy ways for, IT and other users to access to be able to build these solutions on top of it.
Yeah, and I think the area of data, a very logical place is to get that OT data under control. And Kevin, I've heard you say many times actually, sort of the IT side of that is get your digital product house in order, right? So, I mean, those are kind of foundational elements. But in terms of where folks can start, I think once you have that foundational concept in place, in manufacturing, it's really simple. You know, use the MPM link capabilities to purposefully extend that engineering content down to the factory floor, and then use technologies like CWC and DPM as the way to deliver, measure, and enable that closed loop process. In the field, it's very similar to that. Again, start with getting your digital product suited to enable configuration-specific product views in the field, but then leveraging capabilities like ThingWorx to do connected product management or product intelligence, where everybody can see, whether you're in engineering or your service tech in the field, what the status of those products are. And these are basic capabilities in ThingWorx on the IoT side, but then leveraging PLM and Creo up in the design side of the house.
Yeah, so I mean, it's a bit, what I'm hearing is like create a closed loop mindset to say, okay, great, you have your PLM data, let's use that, get into the factory and into the field, and then let's close the loop with important data coming back from the product in the field or coming back from factory operations that may affect the product design or certainly the process design. So I think it's a good spot for us to wrap it up. So we talked a little bit about IoT, PTC's view of PLM's importance in IoT use cases and IoT data, importance in product design and in engineering. Talked a little bit about solutions, and we talked about how to get started. So thank you, Howard, and thank you, Abby, for joining me for this conversation today. That was really good.
Yeah,
Thank you.
Great.
Great to chat.
Thanks.
And thanks to everyone for joining us for this roundtable. Appreciate it.